Welcome you all to the 2023 Chemistry MCQ paper discussion. This Chemistry MCQ paper discussion will be done as a video series, and this first video gives the discussion for the first 10 MCQs of GCE A-Level Chemistry English Medium MCQ paper. Right, the first question: if the wavelength of radiation used in a microwave oven to heat food is 1.1 centimeter, the energy of one photon of this microwave radiation is. And they have given the Planck's constant as 6.6 into 10 to the power minus 34. Right, so what is the equation to calculate the energy of one photon? That is E equals hc over lambda equation. Then h is 6.6 into 10 to the power minus 34 joule seconds times c is 3 into 10 to the power 8 meters per second times lambda is it is given as 1.1 centimeter, so you have to convert it into meters. Then 1.1 into 10 to the power minus 2 meters. So here 1.1 into 10 to the power minus 2 meters. Then we can simplify this, right? So here 6, then here 10 to the power minus 32, then 6 times 3, that is 18. 18 into 10 to the power minus 32 plus 8. Minus 32 plus 8 means there is minus 24. Then we can write this as 1.8 into 10 to the power minus 23 joules. So the answer is 3. Answer is 3 for the first MCQ. Next we will move on to the second MCQ. From the list given below, identify the emission lines in the hydrogen spectrum that have the highest frequency and the lowest frequency respectively. And they have given some emission lines. So it is better to draw these emission lines. So first we will draw these energy levels. N equals 1. Then N equals 2. N equals 3. N equals 4. And N equals 5. Right? Now we can plot the energy levels. First one, they have given 3 to 1. Next, they have given 2 to 1. Next, 3 to 2. Then 4 to 2. 4 to 2. Then 4 to 3. So these are the energy levels. So these are the emission lines they have given. So now you all know when there is a transition from one level to another level and energy is emitted, right? And what happens to this energy? When we go from n equal 1 to n equal 5, the energy increases. Energy increases. Then what can you tell about this energy gap? This energy gap, what happens? Energy gap decreases, right? Energy gap decreases because the energy levels come closer to each other when we move from n equal 1 to n equal 5. Therefore, the energy gap decreases. Now, when an emission happens, this energy is released now, right? So, the energy, what is the energy release? That energy is equal to the energy gap between the energy levels in which that electron got transmitted, right? So if we look at the energy gap, then we can identify the emission line with highest frequency. So in order to get the emission line with highest frequency, the energy gap should be highest. So when you see these 5 emission lines, in which emission line we can see the highest energy gap? That is from 3 to 1, right? So this is the highest energy gap we can see. So this is the highest energy gap. Therefore, this gives the emission line with the highest frequency. So the highest frequency emission line is from n equal 3 to n equal 1. So first answer, you can find that 1. N equal 3 to n equal 1. Here also, yes, here also there. But then we can neglect 3 and 5 because they say 2 to 1. Now, what is the emission line with lowest frequency? Lowest frequency line is the energy gap should be lowest, right? Then for the lowest frequency, energy gap lowest for the lowest frequency. So lowest frequency is seen in which, the lowest energy gap is seen in which line? That is this one, right? This is the lowest energy gap. This is the lowest energy gap. So that is what? N equal 4 to 3. So the answer is second one. Answer is second one. Answer 2. Right? Right. Next we'll move on to the third question. When the compounds given below are heated, they decompose according to the reaction M carbonate when decomposed giving M oxide plus carbon dioxide. Identify the compounds with the lowest decomposition temperature. Now, this is regarding what? Now, this M carbonate means this should be a group 2 carbonate because in all these answers also they have given what? Group 2 carbonate. So, let's see the group 2 carbonates. Right, in group 2 carbonates, you find beryllium carbonate. Then we have what? Magnesium carbonate, calcium carbonate, strontium carbonate and barium carbonate. Now what happens to upon thermal decomposition? This gives beryllium oxide plus carbon dioxide. Then magnesium carbonate gives magnesium oxide plus carbon dioxide. Right? So they are asking to identify the lowest decomposition temperature, compound with lowest decomposition temperature. We know that down the group, what happened? Thermal stability increases. Thermal stability increases, therefore the decomposition temperature increases. Thermal stability increases, therefore decomposition temperature increases. Decomposition temperature increases. So what is the compound which have the lowest decomposition temperature? That is beryllium carbonate. So the answer is 1. Answer 1. Right? Now why this happens? Carbonate anion is same. Now all these three are ionic compounds and the anion carbonate is same in each. Then the cations are different, right? So what happens? Beryllium 2 plus, magnesium 2 plus, calcium 2 plus, strontium 2 plus, barium 2 plus. Then what happens to their size? Which has the highest size? Barium 2 plus. Lowest size is for beryllium 2 plus. Right? Now down the group what happens? The size of the cation increases. Right? Now we know that in order to have a high ionic character, the size should be high. The ionic radius should be high for the cation. Right? The cation should have a large size and that is the one with the highest ionic character. Because for the covalent character, you all know when the size is smaller and charge is high, covalent character is increased. Covalent character for cations is increased when size is lowered and charge is high. Then now what happens in this direction? The size increases, which means the ionic character increases. So when ionic character increases, then they are having high decomposition temperatures. Right. Next, we'll move on to the fourth question. The electron pair geometries around the central atoms of F2IO2 plus. Right. So we have been given some compounds. Now, if there is someone who cannot draw the Lewis structure, because of them, I'll show how to draw it. Right. So, without going to the answer directly. F2IO2 plus. So, how do I get this structure? I should identify the atom with the lowest electronegativity, and that will come to the center, and high electronegativity atoms will surround this one. Then we have to count the valency electrons. Total valency electrons we have to take. Right? How can we take the total valency electrons? First, F2. F2 means 2 times 7. So, 14 electrons. Then, I is there. Right? Then, we are getting 7. Next, 2O. 2O means 2 times 6, because now here how do I get it as 7? Because you all know iodine in group 7, they have 7 valency electrons. Right? Only we have to consider the valency electrons when drawing these Lewis structures. So here there are 2F. So each fluorine atom has 7 valency electrons. So 2 times 7, 14 valency electrons. Then iodine, also in group 7, it has 7 valency electrons. And oxygen, it has 6 valency electrons. So 2 times 6, 12. Then when you sum them, get the sum of them, 4, 7, 11, 13, 33. Now out of these 33 valency electrons, there is a plus charge. Plus charge is there. So you have to minus 1. Then we are getting 32 electrons. Right? Then how many pairs are there? Pairs is 32 divided by 2. 16 pairs you can get. Right? Now out of these 16 pairs, already how many pairs are there? 4 are there. Now remaining is 12. Now these 12 we have to plot for these. Now the 12 is finished. Right? There is no one to come for iodine. Now iodine, it has still 4 valency electrons in its outer shell, and in order to fulfill the valence electrons of iodine, we can give 1 electron from this one and from this. Now how many? 1, 2, 3, 4, 5, 6. And others he can't take. No, there is no other way to get another electrons. Right? So, iodine will have a plus charge here. Why does iodine get a plus charge here? What is the reason? Because here iodine has 1, 2, 3, 4, 5, 6. 6 valence electrons. But iodine should have 7 valence electrons. So, it is in deficiency for 1 electron. Therefore, it gets a plus charge there. Right? So, similarly, when we draw the Lewis structures of the others as well, now before going to the Lewis structure of the others, let's see the electron pair geometry of this one, F2IO2 plus. So, how can we get the electron pair geometry? We have to get the number of VSEPR pairs. So, how many VSEPR pairs does it have? Now, this one we have to consider as 1 unit. Right? So, here 1, 2, 3 and 4. 4 VSEPR pairs around iodine. So, then what is the electron pair geometry? Electron pair geometry, if there are 4 valence VSEPR pairs, The electron pair geometry is tetrahedral. Tetrahedral. Now let's see the answers. F2IO2 plus is the first one and they ask in respectively. So tetrahedral is given in answer 2, 3 and 4. Right? Now let's see the other answers of this second one. Seesaw square pyramidal. This one seesaw octahedral. This one trigonal bipyramidal octahedral. Now before going for the other Lewis structures, when we see the answers of these, right, you all can get the answer even now. Why? Because you all know that seesaw is a shape. It is not an electron pair geometry. Here also seesaw is a shape and square pyramidal is also a shape. Right? Because the electron pair geometries are these. VSE number of VSE PR pairs. And if we get the electron pair geometry, right? If there are 2, then the electron pair geometry is linear. 3, trigonal, planar. 4, tetrahedral. 5, trigonal, bipyramidal. 6, octahedral. Right? So seesaw it is a shape. Right? And trigonal, now these electron pair geometries are contained in which answer? So second, it contains this shape seesaw and square pyramidal is also a shape. Here fourth answer, it contains seesaw, so it is also wrong. Then fifth answer, tetrahedral, trigonal bipyramidal octahedral. So the answer is 5. So without even drawing the other 2 Lewis structures, you can get the answer directly by drawing only one. Right? And then you can spare your time. But in order to complete the discussion, I will draw the other 2 Lewis structures as well. And if we draw for F2BRO2 minus, right? So we will get like this. BRO F2. Right? So this has how many VSE PR pairs? 1. Right? Here 1. Here 2. Right? 1, 2, 3, 4 and 5. 5 VSE PR pairs. So 5 VSE PR means what is the electron pair geometry? Trigonal bipyramidal. So answer is okay. Then now for this one only we get the seesaw shape. Now the electron pair geometry for this structure is trigonal bipyramidal and it has 4 bond pairs and 1 lone pair. It has 4 bond pairs and 1 lone pair. So the shape is seesaw for this one. Right? But we don't need the shape. We need the electron pair geometry. So the answer is 5th, that is tallying with that. Next, we'll draw the other structure as well. IBrCl3 minus. IBrCl3 minus. Right? So this one, if I draw, I will get like this. And here it has 2 lone pairs. And this one, iodine gets a minus charge here. So there are 2 lone pairs and 4 bond pairs, altogether 6 VSE PR pairs. So 6 VSE PR pairs means the electron pair geometry is octahedral. So answer is 5 for the 4th question. Next we will move on to the 5th MCQ. First we will draw this structure. OH, CH, CH3, CO, CH, NH2, CH, CH2, right? CH, NH2, CO, CH, CH3, OH, right? Now we have to get the IUPAC name now, right? So we have to find the parent chain here, and it should have a high number of carbon atoms, and also it should contain the major functional groups, right? And also we have to number it in which order? We have to number it such that the higher priority groups get lower numbers, right? So what is the way to number this? Now if we take the priority of this one, how will be the order? Now in this type of questions, it is better if you first circle the priority groups. So the priority groups, this one, alcohol group is there, then here is a ketone, amine and a double bond, right? Now we have alcohol, ketone and amine and the alkene. Alkene is down now. So what is the highest priority from alcohol, ketone and amine? That is ketone. Ketone has the higher priority. Next is alcohol and then amine. Then we have to number it in such a way that these functional groups get lower numbers, right? So what is the way? Now if I start from here, what happens? Here if I take 1, 2, 3, 4 like that, then ketone gets 4 and hydroxyl group gets 5, right? But if I number it in this way, what happens? 1, 2, 3, 4, 5, 6. Then I am getting lower numbers for the higher priority groups. See, hydroxyl get 2, then ketone has this 3 and amine has 4. So this should be the way, right? 1 and this should be 2, 3, 4, 5 and 6. Right. Now we have to name it, right? We found the order also. Now we have to name it. Then you all know when we are naming it, we have to follow the alphabetical order. We have to follow the alphabetical order. Then we have to write the substituent groups first now. Then first we have to write this is amine, this is one and this is the alcohol. Now as highest priority one is ketone, right? We have to end with it with the suffix on, right? End with suffix on. Then out of amine and hydroxyl, which one? Now if we order it in the alphabetical order, which one comes first? Amino, right? So 4-amino, 4-amino, then 2-hydroxy. 4-amino and 2-hydroxy, it is contained only in the fourth answer, right? Other answer we cannot see like that. So 4-amino, 2-hydroxy and hex 1, 2, 3, 4, 5, 6. 6 carbons are there, hex. Then 5N and 3 on, right? So that is correct. So the answer is 4 for the fifth question. Next we will move on to the sixth question. That is regarding the solubility products. Solubility products of some metal chlorides at a given temperature are listed below. So the metal chloride is given and the solubility products are given. In which sequence are the metal chlorides arranged in the order of increase in chloride ion concentration? So they are asking what? Chloride ion concentration, right? So that is important, and in the increase in order of the saturated aqueous solutions. So what we have to apply here? KSP, right? Right, so PbCl2 first, if I take PbCl2, it gives Pb2 plus aqueous plus 2Cl minus aqueous. Here it is solid. Now how about the solubility? If X is soluble here, this will be 2X. Then Ksp equals Pb2 plus aqueous into Cl minus aqueous squared. Why? Because it has 2 here, so it becomes squared. Then X into 2X squared, so it is 2 squared is 4, X squared times X, X to the power 3. So 4X to the power 3 is equal to the solubility product 5 into 10 to the power minus 7. 5 into 10 to the power minus 7. Now 5 into 10 to the power minus 7, if we divide this by 4, we are getting 1.25 into 10 to the power minus 7 equal x to the power 3. Then in order to get the cubic root, I can make it as like this and get the cubic root. Then I am getting what? 5 into 10 to the power minus 3 moles per dm cube. Now this is x, right? This is x. But Cl minus concentration is 2x, which means 2 times 5 into 10 to the power minus 3. Cl minus concentration is 10 into 10 to the power minus 3 moles per dm cube, right? So this is for lead 2 plus, right? Next, what is the other one? CuCl. CuCl solid, it gives Cu plus aqueous plus Cl minus aqueous, and this here is x and x. Ksp equal Cu plus aqueous, Cl minus aqueous. So here x times x, right? So this is x squared now. Then x squared is equal to the Ksp value. Ksp value is given 1.6 into 10 to the power minus 7. So in order to get the square root, I can make it as 16 into 10 to the power minus 8 and get the square root. So 16 square root is 4 into 10 to the power minus 4 moles per dm cube. So this is equal to x, and our Cl minus concentration, it is also equal to x, right? Therefore, we are getting it as 4 into 10 to the power minus 4 moles per dm cube, right? Now see our answers. Now we got 2 answers now. So let's see whether we can neglect some answers. Now this is A, right? A Cl minus concentration is this and B's one is this. So what happens? B is lower than A, right? Because B is 10 to the power minus 4 times and A is 10 to the power minus 3 times. So B is lower than A. Even if you take into 10 to the power minus 3, it will be 0.4 into 10 to the power minus 3. So obviously B is lower than A. So what are the answers which contain B lower than A? B is lower than A means A is higher than B. Ne? We have to get like this thing. Ne? Right? So 1 we can neglect. 2 is okay because it has BA. Here also this is wrong. Here we can take it, right? A is greater than B now. Here we can't take. So we can neglect 3 answers, right? Now we are there with DC and CD. So even if we get another one, we can get the answer, right? Next we'll move on to the C. So I am lacking space, so I'll use here. Right, now let's see C, which is AgCl. AgCl solid, it gives Ag plus aqueous plus Cl minus aqueous. So this gives x and x. and AgCl, that is 1.6 into 10 to the power minus 10. This is equal to x squared, right? So I'm not going to write again. So if you write KSP should be equal to Ag plus aqueous concentration times Cl minus aqueous concentration. Now then if I take the square root, 1.6 into 10 to the power minus 10 square root, it is like this now. So we can keep it like this, no need to simplify, right? So that is 10 to the power minus 5 times. Now it is 10 to the power minus 5 times. So it is lower than both B and A, right? So C should be lower than both B and A. So from that we can go with answer 4, right? So answer 4 is the answer. Why? Because C is lower than both B and A. Here C is greater than A, right? So the answer is 4. No need to even calculate D. So, but in order to complete the discussion, I'll discuss for D as well. So, Hg2Cl2, it will give a solid. So, actually we no need to continue further, right? We can get the answer like that. Hg2 plus aqueous plus 2Cl minus aqueous, no? Here we have to take 2Hg2 plus, right? So Hg2Cl2, here this is Hg2 plus, right? So here we are having 2, yeah, right. So here 2x and we are getting here, this is Hg2 to 2 plus 2Cl minus. So this is the equation we are getting, Hg2 to 2 plus 2Cl minus. Then here we are getting it as x. X and here 2x. Then Ksp is Hg2 to 2 plus aqueous into Cl minus aqueous squared, right? Then x into 2x squared. So we are getting it as 4x to the power 3. Then 4x to the power 3 is equal to what? 1.08 into 10 to the power minus 16. 1.08 into 10 to the power minus 16. So as I have to take this cubic root, I can make it as in this way, right? Then I can divide it by 4. X to the power 3. 108 divided by 4 is what? That is 27, right? 27, yeah, that is 27. Then 27 into 10 to the power minus 18 cubic root is x. So x is we are getting as 3 into 10 to the power minus 6. Now x is 3 into 10 to the power minus 6, but in Cl minus we have 2x. So that is 2 into 3 into 10 to the power minus 6, which is 6 into 10 to the power minus 6. So here we get it as 6 into 10 to the power minus 6 m. For the C we got it as root 1.6 into 10 to the power minus 5. Then for B we got it as 4 into 10 to the power minus 4. And for A we got it as 10 into 10 to the power minus 3. Right? So we can go with the answer 4. Next, 7th question. Select the incorrect statement. Ionic radii of isoelectronic monoatomic ions decrease when nuclear charge increases. Ionic radii decrease when nuclear charge increases. Yes, that is correct. Why? Now, when the nuclear charge increases means what happened? The number of protons is increased, right? The nuclear charge gets due to the charge of protons. So here the number of protons is higher. So it has more positive charge. Therefore, the electrons tend to shift more towards the nucleus. So they will be contracted towards the nucleus. So the ionic radii, what happens to the radius then? Then the radius decreases. Why? Because the energy levels are shifted towards the nucleus. Therefore, the ionic radii decreases when nuclear charge increases. So that is correct. Then second one, helium atom is the smallest among all atoms. Yes, that is correct. Because now if we draw the periodic table, now here hydrogen, helium, then lithium, neon, right, sodium, argon, potassium, calcium likewise. So now what happens across a period? Down a group? Radius increases down a group. Why? Because when we move down a group, the number of energy levels increases. When the number of energy levels increases, the radius increases. Then what happens across a period? Across a period, radius decreases. Why does it decrease? Due to the increase in nuclear charge, right? Now across a period, the nuclear charge is increased. Higher number of protons are there. So the electrons are shifted more towards the nucleus. Because there is this, now across a period means there is the same number of energy levels now. Now if we take the second period, everyone has 2 energy levels. So the number of energy levels is same. Then why does the radii decreases across the period? That is because the nuclear charge increases. Right? Nuclear charge increases and electrons are being added to the same level. Then what happens? Those electrons are shifted more towards the nucleus because there are more number of protons. Nuclear charge is high. Right? Now, when radius decreases across a period, therefore, these ones should have the lowest radius, and across down a group, the radius increases, which means group 1 should have, the period 1 should have the lowest radius. Then out of hydrogen and helium, helium has the lowest radius because across a period, the radius decreases due to the increase in the nuclear charge. So, second one is correct. Helium is the smallest among all atoms. So, that is correct. Next, radius of sodium plus is larger than the atomic radius of lithium. Yes. Why? Because, radius of sodium plus is larger. No, it is wrong. Radius of sodium plus is larger than the atomic radius of lithium. Wrong, because cations have lower radius than the neutral atoms. Cations have lower radius than the neutral atoms. So, sodium plus is having a lower radius than the neutral atom lithium. Right? Why? Because it has a more number of protons. So, when the number of protons is higher, they are getting a plus charge now. So, because of that, the energy levels are shifted more towards the nucleus. Therefore, the radius will be lower for sodium plus than lithium. Right? So, that is wrong. Third is wrong. So, third one we can get as the answer. Again, we'll see the others as well. Potassium fluoride shows the greatest ionic character among lithium iodide, Kf and Ki. Right. So, now if we take lithium and lithium, sodium, potassium now. And here we have fluorine, chlorine, iodine. Now, these form cations now. These form cations. So, now what? Now, they are asking about the ionic character. So, ionic character increases in cations when radius is larger. Right? So, down the group what happens? their radius become larger, therefore highest ionic character for potassium. Highest ionic character out of this. Now if we take fluorine, chlorine and iodine, they form what? They form anions. And for the ionic character, higher ionic character for anions is when the size is larger or the radius is smaller. Ionic character is larger when the radius is smaller. Ionic character is larger when the radius is smaller. Right? Which means fluorine has the highest ionic character here. Fluorine has the highest ionic character here. So then out of the compounds which are formed from these elements, potassium fluoride should have the highest ionic character, right? And so that is correct. Kf shows the greatest ionic character among lithium iodide, Kf and Ki. That is correct. That is correct. Then xenon has the highest boiling point among noble gases. Here, no, that is wrong, because below xenon there is radon, right? Now if we get the group 8 elements, helium, neon, argon, xenon and helium, neon, argon, krypton, xenon and radon are there. So xenon is not at the bottommost. Radon is the bottommost one. So radon has the highest boiling point. So fifth one is also wrong. So there are two answers which are incorrect as answer 3 and answer 5. Right? Next we will move on to the 8th question. The increase in order of electronegativity of the underlined carbon atom in right, they have given some structures and we have to identify the increase in order of the electronegativity of the underlined one, right? Underlined carbon atom. Right, so now first we'll draw these structures. CH3, CH2, Br, and this is the carbon that we should consider. Then CH2, double bond, CHF. Then CH2, double bond, CHCl. Then C triple bond, CFF. So here we have to consider this carbon, here this carbon and here this carbon. Right. Now first, when we are, what are the factors that affect the electronegativity? The factors are, first we have to consider about the hybridization. Right. First we have to consider about the hybridization. Second, we have to consider about the formal charge. Third, we have to consider about the oxidation number. Fourth, we have to consider about the electronegativity of the atoms which are bonded to the considered atom. Atoms bonded to the considered atom. Right? So we have to consider these factors. Now, what happens in the hybridization? sp hybridization has the highest electronegativity. Why? Because highest S character for sp. Highest S character for sp. That's why it has the highest electronegativity. Right? sp has the highest electronegativity because S has the S character there is 50%, which is the highest S character. Right. So now if we see the hybridizations, this carbon is, I'll use another color. This carbon is sp3 hybridized because it has 4 VSEPR pairs. 1, 2, 3, 4. 4 VSEPR pairs. So that is sp3 hybridized. Here 1, 2, 3 VSC-PR pair. So this is sp2 hybridized. And here 1, 2, 3, here also sp2 hybridized. Here 1 and 2, here sp hybridized. Right, so this one is only the one which is having sp hybridization. So HCCF that should have the highest electronegativity. So when we check the answers, we are getting this one and this one, right? Others are wrong. So we could neglect 3. And what should be the lowest one? CH2Br should be the lowest one. So both of these are lowest. Now we have to consider these two. Now formal charge. There is no formal charges in this carbon, right? They have no formal charges. Now then, if we consider the oxidation number, now how do we find the oxidation number? By seeing the difference of the electronegativities. Here it gets minus, here plus for hydrogen. Here this one gets plus, minus. Here there is here there is no oxidation number, right? Right. Next one, if we see this one, here minus, here it gets plus, here no, here also the oxidation number is 0. So the oxidation number is also same for both. Next we have to go for the electronegativity of the atoms bonded to the considered atom. Here carbon is bonded to hydrogen and fluorine. Here carbon is bonded to hydrogen and fluorine. So the difference is the fluorine and chlorine atoms. Out of that, fluorine has the highest electronegativity. Fluorine has the highest electronegativity. So we can say that this one has the next highest electronegativity because both of these are sp2 hybridized. So if the both of them are sp2 hybridized, sp2 hybridized should be higher than sp3. So then out of these two, CH2F should have the higher electronegativity, right? So answer is 4, right? Answer is 4 for the 8th question. 9th question, which of the following represents a chain propagation step in the free radical chlorination reaction of methane, right? So this is the chlorination reaction, right, of alkanes. Right, so if we take the mechanism, it has 3 types of steps. Chain initiation steps, chain propagation steps and chain termination steps. So they are asking about a chain propagation step. Right, so if I write first the initiation step is this one. Cl. First the Cl bond should be cleaved, right? So it forms 2Cl dot. How? By this cleavage of this. Next, so this is the chain initiation step. Next comes the chain propagation steps. So now the chain is initiated. Now the chain should propagate. Chain propagation steps. Right, first one. Now for the free radical chlorination of methane, that is CH4, right? So CH4 we can write it like this, CH3, and we are considering one CH bond here. Right, this one is cleaved like this because of the radical from chlorine. Right, this radical, it reacts with this, comes to bond with this H, and it will form dot CH3 plus HCl. Then this dot CH3 will again bond with the chlorine. A chlorine bond will be cleaved, and this will form CH3Cl plus Cl dot. Now we have ClCH3. So another CH bond we have to consider. We have to consider another CH bond. So when we consider this again, now what should react with the CH bond? The chlorine radical, right? This one. So this comes with this, and this forms CH2Cl dot plus HCl, right? Again we have to take CH2Cl dot, again it comes with the Cl. So this is cleaved, and this will form what? CH2Cl2 plus Cl radical. Now likewise it will propagate again CH2Cl2, again we have to take a carbon hydrogen bond, right? Again we have to take a carbon hydrogen bond, so again it will be like this, and again a chlorine radical will come for the reaction of this, right? And this will form again dot CHCl2 plus HCl. Then this dot CHCl2 plus again a chlorine bond, right? Again this will form CHCl3 plus Cl2. So likewise it will continue until it becomes CCl4, right? Until it becomes CCl4. So there is another 2 steps more, right? To form CCl4. Now let's consider about the chain termination steps. So how can this chain be terminated? Chain termination steps. So the chain termination steps, so you all have to remember these steps, right? Cl dot plus CH3. These radicals can join together and form CH3Cl. Then CH3 can come together and form C2H6. Then Cl can come together and form Cl2. So these are the chain termination steps. Now they are asking about the chain propagation steps. Now this one is CH3Cl plus Cl dot. See whether we have something like that. CH3Cl dot. Now this one CH3Cl. No, yeah, this one is the one. CH3Cl plus Cl dot. It must give CH2Cl dot plus HCl. Hydrogen radicals are not formed, so that is wrong. Second one, see, CH2Cl2 plus Cl dot. See that one. Now that is this one, right? CH2Cl2, right? CH2Cl2 plus Cl dot. It gives CHCl2 dot plus HCl. So that is the correct answer, right? So that is the correct answer for the 9th one, second one. We'll move with the others as well. CH3Cl, CH3Cl, that is a termination step. That is a termination step. Then CH3Cl, CHCl3 plus Cl dot. Let's see that one, CHCl3. We stopped from here now. So if this continues, then it will form with CHCl3 plus Cl dot. It will give not this one, right? Because here they form a radical. CCl3 radical will be formed. So that is wrong. Now if that happens, right, CCl3 radical is formed because here CHCl3 now. So we have to cleave the carbon hydrogen bond like this. For that it will come this chlorine radical and it will form what? CCl3 radical plus HCl, not CCl4. This is wrong. Then ClCl given Cl2, this is a termination step. So this is also wrong. The answer is 2. Answer is 2 for the 9th question. Next we'll move on to the 10th question. The experimentally determined rate law of the reaction A2 plus B2 given A2 B2 is rate Ka2. Here K is the rate constant. The following mechanisms are proposed for this reaction. So they are giving that A2 plus B2 reaction given A2 B2. They have given the rate law as this is equal to Ka2, right? So they are asking the following mechanisms are proposed for this, and there are 3 mechanisms given, right? And all these mechanisms are multi-step. Multi-step mechanisms are given. Multi-step mechanisms are given. Which of the following statements is correct regarding the above reaction? So let's go through the answers first, and we can get an idea what type of answer they are expecting. Mechanism 1 and 2 are consistent with rate law. 2 and 3 are consistent with rate law. Alright. So they are asking what are the mechanisms which are consistent with the given rate law. What are the mechanisms which are consistent with the given rate law? So let's see. Now for the first mechanism, right? So there are mechanisms now. For a particular reaction there is a mechanism. And now they are asking what is the mechanism which is applicable for the given rate law, right? Now if we see this first mechanism, it is a multi-step reaction because there are 3 steps. Then in a multi-step reaction, the rate determining step is the slower step. In a multi-step reaction, the rate, this is very important point, right? This is a very important point. In a multi-step reaction, the rate determining step is the slower step. So here this is the slower step, right? And if we write the rate law for this, we can get R equals K1 A2. So if I take it as K1, right? Then here we can take, we can take it as K, right? Okay. Then here we can take rate equals K A2 again. Why? Because this is the slower step. Then here again the slow step is this one. So here also R equals Ka2. So from this we can say that all the 3 mechanisms give the same rate law, right? Gives this given rate law. Rate law equal Ka2. This rate law is given by every mechanism, which means that all the mechanisms are consistent with the rate law. So all the mechanism 1, 2 and 3, all 3 are consistent with the rate law. So the answer is 5 for the 10th question. Right.